Namaskar and good afternoon to all of you. Today we have with us respected Professor A.K. Sinhaji, Vice Chancellor, Chhatrapati Shivaji Maharaj University, Mumbai, as we are celebrating the World Water Day today. Annually, it is celebrated on 22nd March to promote the responsible usage of water and to address the sustainable management of the water. And World Water Day, I feel will have different themes every year. And if I'm not wrong, this year the theme is accelerating change. So with this, I extend a very warm welcome to you, sir. And I sincerely invite you to the dais. And I request our director to accompany Professor Sinha. And I also welcome all the scientists from other organizations as well. Thank you so much for your presence here. And I invite Payal to present a bouquet to Professor Sinha. I request Chai Chaudhary to present a bouquet to our director. I now request our director to place his opening remarks.
Chief guest, Professor A.K. Sinha ji, Dr. Mangli Shab, Dhar Shab, Thangarajan Garu, Verma Shab, Venkatasara Garu from GNTU, Madhu Nure Shab, senior scientists, and students. Good afternoon. First of all, let me say my belated greetings to all of you on World Water Day. Because of some unavoidable circumstances, we postponed this from 22nd of March to today. As we know that World Water Day is an annual United Nations Observance Day held on every 22nd March and highlighting the importance of water, fresh water. And it is mainly focuses on reducing the wastage of water also. Today we have a very distinguished chief guest and speaker, Professor A.K. Sinha Saab, Vice Chancellor, Chhatrapati Shivaji Maharaj University, Mumbai. And in his entire career, he remains a veteran and co-founders of quite a number of institutions in India. I, on my personal behalf and behalf of CSIR NGRI, extend a warm welcome to you, sir, accepting our invitation and readily agreeing to deliver a talk on this very important day of NGRI. As we know that there are three essential elements of human to survive on the earth. That is air, water, and food. Now, kapda and makan have been replaced. More recently, the increase of our population, in fact, leads to the overuse of resources. And according to the research, about 600 million people are living without the pure drinking water in our country. Therefore, in this context, the accelerated growth or accelerated activity is very much important. And therefore, the today's talk is very relevant, illuminating, and probably it will be a very educative also on accelerating changes on groundwater sustainability, which is also a part of our SDG goal 6 of UN. So with this, I would again like to express my deep gratitude to Professor Singh Saab for agreeing and coming here out of his very busy schedule and spending his valuable time for giving a very thoughtful and very illuminating talk of today's. Thank you very much, sir.
Thank you, sir. I now request Dr. Payal to introduce our chief guest today.
Thank you so much. Good afternoon, everyone. So it's my honor to introduce our distinguished speaker today, who is Professor A.K. Sinha. So as you all heard that he is Vice Chancellor at Chhatrapati Shivaji Maharaj University, Navi Mumbai. And also he is the President of Indian National Chapter of International Association of Hydrogeologists and founder chairman of Groundwater Community Forum. Professor Sinha holds a master's and PhD in geology from Patna University and MPhil in environmental sciences from Jawaharlal Nehru University, New Delhi. And Professor Sinha has vast experience in working in groundwater management and policies in India. His research interest mainly concerns study and management of groundwater quality, recharge, climate change, seawater interaction. He has published more than 80 research papers and several books and has delivered several lectures and invited talk across the world. He has contributed significantly in the development of groundwater management policies in India and also developing curriculum for different universities as a subject matter expert for geology in the Board of Studies. His past roles include, but not limited to, professor and founder head of Department of Geology, University of Rajasthan, Jaipur. He was also convener of the Rainwater Harvesting Committee and founder director, Center for Water Resource Management and Research, University of Rajasthan. He also served as Dean, Research and Director, Center for Water and Climate Change, Suresh Gyan Vihar University, Jaipur. And he was also the Director of Manipal University, Jaipur, India. Apart from that, Sir has been collaborating with many national and international organizations, including UNESCO Intergovernmental Hydrological Program, that is commonly known as IHP, JICA for Japan International Cooperation Agency, and the Indian government with R&D focusing on sustaining the groundwater in arid to semi-arid region of Western India, including the Thar Desert. And he has been member of various reputed professional bodies and various committees as an expert for national and international groups. Sir has been bestowed with various awards and recognition at national and international level, including Government of Netherlands Fellowship, UN Fellowship, Electrotech Geometric Endowment Lecture Awardee 2015, member International Scientific Committees, chairman technical session of various international national events held in India and abroad. He is also involved in promoting the groundwater management policies, perspective, and also a keen promoter of the groundwater management in the entire country. So with this brief introduction, I welcome you here, sir, and invite you to deliver your lecture on this very interesting topic for us. And we are very much looking forward to hear from you. Thank you so much.
Dr. Prakash Kumarji, Director, NGRI, Professor Venkateswara Rao, Professor JNTU, Dr. Madhunje, Director, State Groundwater Department, Dr. Dhar Saab, Dr. Thangarajan, all the senior scientists of NGRI and students, research scholars from the NGRI. At the outset, I'm very thankful to Dr. Prakash Kumarji, Director of this great institution, to invite me to deliver a lecture on the eve of the World Water Day that normally falls on 22nd March. But, well, any day is a water day what is such an important subject. So even, today we are here to celebrate World Water Day, and it's a great occasion. I have a little bit to frame my topic, accelerating change for groundwater sustainability in India, in keeping view the theme of this year World Water Day, that is accelerating change. But this accelerating change pertains to the Sustainable Development Goals. I tell you, I hope you are aware of it, that United Nations during 2015 formulated 17 Sustainable Development Goals. Very relevant under 2030 agenda. All these goals are supposed to be achieved by 2030. And one of the important goal number 6, SDG 6, is pertaining to sustainability of water and sanitation. Hygiene, water and hygiene. But water is very fundamental, water is very basic and interrelated towards the achievement of the other goals also, like goal number we'll discuss. So there are various goals. The water is very fundamental, and water, as you know, is very important for all of us, and not today, but right from the dawn of the human civilization. I want to quote before you this stanza from the third Ved. Ability to see, hear, and speak are useless in the absence of adequate water. Water is the basis of life. Most life forms are born and live in it. Most life forms are born in water and live in it. It is not love in it, live in it. Oh, water stream, come near to me. You are leader of immortality. So you see, our ancestors were so much concerned about the sustainability of the water. They knew that water is very basic, and all of you know that many civilizations thrived along the water courses and vanished because of the mismanagement of the water sources. And this stanza also serves as a forewarning to us, because the situation in which we have landed pertaining to the sustainable water is very grave, and had we valued this stanza, practiced it accordingly, probably would have been saved from the situation wherein we find to be today. So I was talking about the sustainability goals. There are 17 goals which have been formulated by the United Nations. And this year's accelerating change pertains to the goal number 6, that is the, pertaining to water and hygiene, sanitation. So why this? And very disgusting is the report which has been given by a committee constituted to progress and monitor the progress of the achievement of these goals. These goals are supposed to be achieved by 2030, but the way we are progressing, we are not progressing, rather we are decelerating. Our work, our effort has become stagnant toward achieving these goals. And in between, the COVID has also decelerated the process. And it has been estimated by the committee that we cannot achieve this goal with this pace of our activity, with this pace of our action plan and all that. And the anticipation is that we may, if we work with the same pace, the goals will be achievable by 2065. So that is very disgusting, very, for all of us, because, without water, you cannot. And this goal is very important because achieve, goal number 1, no poverty, zero hunger, good health and well-being, so many climate actions, so many goals can be achieved only when we have the sustainability of water. And without water, we cannot achieve those goals. So that's why, it needs, that there should be acceleration in our effort to achieve the sustainability. If we look into the distribution of the water, we find that only approximately 3% water is a fresh water. Remaining 97% are confined to sea, the marine water. And out of the 3%, 79% is locked in ice caps, glacier and all that. 1% appears as fresh water in lakes and the rivers, and 20% is underneath. So the groundwater constitutes the most dominant source of fresh water. It constitutes the 97% of all the fresh water available on the globe. And that's why the sustainability of water means sustainability of the groundwater. Because you see our dependency, if you look into the literature and consumptive behavior or consumption pattern of the water, you will find that, we are using the water like anything. And if we use the water with this pace, probably we can never achieve the sustainability of the water. And then we'll have many other problems. So, and then water, when you talk about the sustainability of water, the water has inherent problem. Groundwater has some inherent problem, like it is invisible resource. It is hidden below the surface. It is subterranean water. You are not, when the users are not able to understand its locations, and even they don't rely the recharge mechanism because they feel that, okay, whatever, if you put inside water to recharge, then how we can recoup it, how we can get it back. So such type of problem, such type of faith, crisis of faith is also associated with this groundwater that is a problem. And because you see our aquifer, the geological, formations, they have a different type in nature, and they are very diversified. So that is also a complex situation, and probably we have not been able to understand the disposition of aquifer properly so far. So all this situation make it more cumbersome, complex about the managing the groundwater resources. And what are the challenges? Dimension of sustainability. When we talk about what is dimension of sustainability, that the basic concept of the sustainability, that we should, any resource, if you talk not only about water, if you're talking about the sustainability of any resource or services or process or material, that means that should be available today and should be available in the future also, without compromising the quality and the environmental value of the resources. So is with the groundwater. Groundwater should be available to meet the present requirement, the present demand, and also should be available to meet the future requirement. And besides, it should ensure the water security, because our water security means food security also. So ensuring the water security and also the conflict arising out of the water use should also be resolved. They should have the capacity to resolve. So these are the features, and the satisfying the ecosystem requirement. many ecosystems which are dependent on groundwater, they are groundwater dependent ecosystem, that their requirement also need to be satisfied. If all these three aspects, dimensions are met, then we can think of that what groundwater is sustainable. But there are challenges in it. The challenges is overexploitation. Well, these challenges are there for a long time. I mean, not a new challenges, but unfortunately, the challenges after so much of work by different organizations, institution, individual, NGO at different scale in country and outside, the challenges have remained with little bit of changes in the intensity, but the challenges have remained. That this is also very matter of consideration. The overexploitation and unregulated extraction and excessive irrigations are major cause of overexploitation. And if we overexploit the resources, then what is going to happen? We are exploiting more than 250 cubic kilometer water per annum. And that is groundwater. We are abstracting groundwater more than 250 cubic kilometer per annum. And this volume is more than what China and USA is abstracting together. So this is unfortunate that for the same volume of the material being produced, India is spending or using more water than what other country or developed country are using. So that a matter of a big consideration. Then we have also limiting our resources by polluting and contaminating. Some contaminants are, of course, geogenic, like arsenic, fluoride, salinity hazard, inland salinities are there, iron. So these are geogenic contaminants, but their spatial distribution, their mobility need to be understood. Climate change is, is another big problem and affecting adversely the groundwater, because with the climate change occurring, there is shifting in rainfall pattern and the drought pattern. If you see, the rainfall pattern and drought pattern over the country, all over the globe, but I'm talking about India, have shifted. The northwest region, which used to get the highest rainfall, now we are getting extra flux of the moisture in northeast, which to get the highest rainfall. Now we are getting good flux, extra flux of water moisture in northwest region. And that's why you might have seen that in Thar Desert, we are getting flood. Never heard about before the 2006. So this type of scenario, and this is affecting the recharge pattern of the groundwater. And added with the overexploitation and all these things will be becoming a matter of great concern. Then poor knowledge of groundwater management. We are always looking for the best practices of groundwater management, trying to copy from here and there and trying to replicate in our respective region. But we need to understand our subsurface domain, our geological domain. We need to understand our aquifer disposition, aquifer dimension properly. Of course, a lot of work is going on. And then human-centric approach of management. We are only interested in meeting the demand, individual demand, society demand, institutional demand, agricultural demand. But we are not considering to meet the demand of the ecosystem. We are not considering how the base flow in the river should be maintained, how the dependent ecosystem should be maintained and should survive and sustain. And ultimately, the attitude and ethics. On top of it, many problems are not the resource-based In many areas, we have the resources. I mean, but our attitude is very casual towards water use, whether it may be groundwater, surface water. But I said, I mean, our attitude is very casual. We take the water very casually in our day-to-day use, whether we are using in industries, we are using in our washroom, we are using in kitchen, or we are using in our agriculture field. We want to have maximum with a perception that the maximum water will give the maximum benefit. If we have a more shower, we'll feel more comfortable. But everything should have some limit, you know. If you put more water in a particular crop, farmer think that they will get more better crop yield. So this type of perception, we work with this type of perception, and so this type, the attitudinal problem is also there, and on top of the other important things is ethics. And I feel that there should be hydroethics. People should, whoever is engaged in managing the water, wherever we are using the water, we must have some ethical sense. I don't say that well, people are unethical, but when we try to use the resources, try to, we become little, unethical. We want to grab maximum for ourselves without bothering for the others. So, as Dr. Prakashji said, that 600 people, large number of people, they're not getting the drinking water. If you go to the western region of Rajasthan, Thar Desert, or even many coastal regions, you will find people are not getting water, drinking water. International standard for a good living is 1,000 cubic meter per person per annum. But many areas of India, even I know, because I've been in Rajasthan, I know that people are in western part having much less than the 300 cubic meter per person per annum availability. And with the rise in the population, our water availability has gone down undoubtedly. During 1947, we had almost 5,000 cubic meter per person per annum availability of water. Now it has come down to officially 1,300 cubic meter per person per annum. But practically, if you look and see the some paper of IWMI, you'll find that water availability in many parts is 200, 300 cubic meter per person per annum. So this type of unequal availability is a big problem, and that is, you probably might have noticed or might have come to know that many people from such a region where the water availability is less, they migrate to the urban area in search of job and search of the resources. So there is a large scale migration also. So this type of problem are there, and we need to, but responses are there. I will just skip this thing because this is all about the impact of the work, but all of you know what impact is there of the overexploitation, lowering of the groundwater level, increased energy consumption, because when the water level goes down, then you have to use more energy to lift the water from the deeper bore well. So the energy consumption rises, reduction of well yield, of course, is there. Then spring discharges. Many people who have visited earlier also Shastradhara in the Dehradun region. I can give you because I have also gone there. I don't know about other places in India. You will find that prior to 1970, there were hundreds of springs. But if you go today, you will find none, not a single, one or two springs. They are just managing through gardening it and all that. So this type of situation, of course, the impact of mining is also there, but the diversion of groundwater, the lowering of the level of the groundwater has also caused this problem. If you go to Rajasthan, you will find that badland topography has increased over the years due to the lowering of the water table. Many marginal farmers, they have, because the water table has gone down, many marginal farmers who are dependent upon the dug well, they have sold their land to brick lane owner and they have become the labor. So, of course, it is affecting so much in loading and deepening depletion of the groundwater level, causing so many socio-economic and environmental problems that has to be taken into consideration. And the stream-based flow. I mean, many rivers, if you measure the discharge, forget about the ephemeral river system. I'm giving the example of the Ganga River basin. If you measure the discharge from Allahabad and down the stream, you will find that discharge is decreasing. It is because of the overexploitation of the groundwater. Groundwater used to contribute to the flow of the river. So when the water level in the catchment has gone considerably down, rather river water is getting diverted and the flow become quite lean. आपने सुना होगा कि the former chief minister had to create flow, artificial flow in the Ganga by bringing water so that the Chhat Puja may take place. So such type of a perennial river, and I'm sure after some time, if situation like this, then a perennial river is going to become a seasonal river very soon, and then it will become a paleo river. So this is the way things might develop. And then the wetlands, the groundwater supported wetlands are dying, vegetation patterns are changing. So these are various consequences taking place. The degradation of groundwater quality also, because what is happening, that we are mining, in fact, the groundwater. Normally, there are dynamic component and a static component. So long as you are using the dynamic component, that component which is added to the groundwater resource every year with the rainfall. And static level is that the original level, which is added to, which remain there for older water, you can say. But we have started, forget about the dynamic resource, we are mining the static resources, and when the water level goes down, and you are mining the older water, so you are taking out more mineralized water because of the rock water interaction. Because those water which have remained for a longer duration in contact of water getting more mineralized. So you are starting with a fresh water composition and you end up mining with a saline water composition. So this type of scenario is happening. And many places, land surface topography changing due to the subsidence. Just we were discussing about the Joshimath. Of course, many people are citing seismic conditions, seismic region, but seismic and hydrology, both are responsible there, the groundwater, because, recent past, there have been good rainfall in the area, finding no outlet, they're making through it and washing whatever coming in between, creating a subsidence situation. And subsidence is also taking place in the coastal region, bringing in the accumulation of the tide water, high tide water. So this type of situation, and then not only that, it also inciting the intrusion of the saline water. The coastal groundwater, if you're taking out the coastal groundwater, the balance between the surface groundwater and the seawater, that is lost. And the Haber-Bosch principle, that salt water intrude inside the coast. If you go to Khambat region, large area have been left by the farmers. They are not doing any farming in those areas. Earlier they used to do, because even the soil, forget about due to the saline water intrusion, even the soil have become saline. So they have left the large area as such. They are not doing any farming, or all the agricultural practices have been stopped. So such type of scenario are there. Groundwater quality, I have told you that, well, there are large number of, chemical and anthropogenic chemicals. In fact, as well as, bacteria, microbacteria, they are moving into the aquifer. These are the, I mentioned arsenic, fluoride, salinity, iron, they are all geogenic. But beside that, there are many areas which are witnessing contamination, pollution because of the point and non-point sources. Agriculture, we are very vehemently using the pesticide, insecticides, and they are ultimately going to the groundwater. So these are scenario in our country. Groundwater climate change, I mentioned that it is changing the recharge pattern. Also, making the, increasing the concentration of pollutant in the water because of the climate change. Not only it is a shift, recharge pattern, rainfall pattern or drought pattern is changing, but also it is bringing in enriched, chemically enriched water, which are not useful for the human being. So responses are there. Lot of people are working. NGRI has a good group of hydrology. Similarly, Central Groundwater Board, Government of India, Jal Shakti, Ministry of Jal Shakti, they are all working on the issue. They are seized with these issues. We have seen so many projects being completed, like Hydrology Project 1 and 2, like now another. NGRI has also contributed a lot. They have carried out L1 surveys, part. But problem is the output, the useful output, which should have reached with the society level, that is not obvious. That is not coming. Scientific goods, despite good scientific contribution, they are not, the society is not going benefited, or I should say the attitude of society is not changing. The science should help in bringing attitudinal change of the masses, attitudinal change of the users. So that is lacking. And well, so these are the options which have been, and these options have been there from there also, and for these options, everybody individually, or most of the institution, individual, they have worked on their own, they have tried to contribute, and also, augmenting the groundwater availability through artificial recharge, by diverting the rainwater to the, recharge site. Effort has been made to recharge groundwater through MAR, managed aquifer recharge. You might have heard about this word is being used now. So through MAR, managed aquifer recharge system, the groundwater is being recharged and being practiced. There are traditional wisdom also, which is very much evident in Edisam region, particularly Rajasthan. You might have heard Taka and Kundi, and also many structures. Traditional water harvesting system have been there also. That's why the people in those regions survived for. So, but the basic thing that artificial recharge being promoted, for that you need two things. The one is the water, and one is the appropriate recharge site. Many places it has been seen that recharge being done in the name, because there are scheme, there are money for that, people dig and they put the water. Whether it goes or don't go, they are not bothered. So it is there should be a civil science approach where the scientists and the community should come together, and the scientists should guide them where the water should be put, because you are bringing in water. 65% of water is, of course, from the rain, 35% from other flood water and other, or treated water, or reclaimed water. But this water, the sources should not be wasted, should be put into right place, so that then the artificial recharge would be meaningful. Then prospecting an explored area, such as hard rock area like in Hyderabad and all these regions, you have the very hard rock area. And paleo channels in a coastal region, in alluvial region of northern states, you have paleo channel. So this still have the potentiality, and that potentiality need to be explored in a very integrated manner. Enhance the storage for imported water. As I said, water had to be imported. Water is not for the recharge water. I mean, you cannot have on the same location. Sometimes you have to import it. So, but you should have a place where you can store it. And nowadays, I will come for subsurface and create awareness toward conservation and national management. Conservation is another way by which you can save the water, particularly groundwater. If you want a sustainable groundwater management, you have to adopt a recharge system, and recharge may be natural recharge, and maybe artificial recharge through rain and all that, and then indirect recharge, that is return recharge. I mean, when you put the water in farmland, then the part of it goes to groundwater and recharge it. So there is a indirect way of recharging also. And all they have their economic value, environmental benefits, and human benefit. So these all three components are very essential for the sustainability. So these three features are made by undertaking the recharge of the groundwater. And for that, yes, I mean, the subsurface domain. There is a controversy about the dam, surface reservoir versus subsurface reservoir. Surface reservoir, all over the world, more than 800,000 dams have been constructed. And surface reservoir cannot store more than 1/5 of the rainwater. And moreover, because of the climate change, increased evaporations and all that, surface reservoir have not remained a very useful proposition for storing water, and then within the contamination and pollutions. So you have to look for the subsurface reservoir. And I understand with a lot of work going on to understand because aquifer mapping is being done very intensively, we will be able to have a good subsurface. You can identify the subsurface storages have been identified and more to be identified, so that the water may be stored in the subsurface domain for future use. We have carried out in Rajasthan, in Data Ramgarh, we have mostly the saline aquifer there. This is one of the work carried out by our group in the Sikar district, where we have the saline aquifer, and the water rainfall is there, but rainfall get wasted and go with the centripetal drainage, go to the playa and all that. So what we divide that, if we along these two ridges, down these two ridges, if we develop parallel trenching, probably this water which get lost as a runoff may go down, may recharge the aquifer. Of course, the water, the surface, the fresh water will go to the saline water, But because of what I feel needs experimentation also, need to be understood. I mean, because of the density difference, what we feel that the surface water may float over the saline water. There may be some interfacing of saline water and fresh water that can be used by, saltwater resistant crops and all that. But of course, in this region, some fresh water will be available for use as a drinking purpose for the local people. This is another area around Jaipur where we try to develop, identify the recharge domain and the way of recharging the groundwater, collecting the, enriching the groundwater by arresting its escape. And we try to identify the which sites of the subsurface dams and all and other percolation tanks, all these sites were identified. Then another issue, probably this project was, I understand when we discussed in the DST, I think Dharsa was there, subsurface, identifying the aquifer. What type of aquifer we have underneath the surface in a particular region. So I was directed, okay, the project will be sanctioned only we give the big scenario of the subsurface aquifer. This was the condition laid down. I said, okay. So we did carried out, survey, geophysical survey, of course, research survey, and tried to build up a model of subsurface. And then we find that there are multiple aquifer. And we propose that the top aquifer should be saved for the grey water, because pollutant and grey water. But the lower, aquifer may be used as a storage for, for recharging by diverting the rainwater. So rainwater can be stored in the lower aquifer rather than in the top aquifer. So that was a, and this is another, we have, I said, the paleo channels in Rajasthan, or I said in coastal region, you have a good network of paleo channels. This is another data which we procured from the Jodhpur. It is a wide field sensor remote sensing data. And myself and my one of students, they worked and tried to identify the type of geological setting in the paleo channels. We found that few of the, on the basis of the borehole data and we found that, yes, there are many paleo channel sites where we have still in riverine environment, and those formations, aquifer, like alluvium, old alluvium, they're all intact. So they can be a good, they are holding the water also, and some where there's space, they can be recharged. So the paleo channel is a good, our proposition had been that could be a good site for looking for the quality water, and also it could be a good site for storing the water, diverting the rainwater, and storing it for the future use. This is a work, carried out using the chloride mass balance technique, tested technique, with the, and there was a team, from USA and ourselves, and Vijit Mukherjee from IIT Kharagpur was also associated with it. Well, because when you are going looking for the recharge, and then you should know what is the recharge rate, whether recharge is possible or not. So in the Jaisalmer area, I was talking about that the recharge was found to be only 2 to 3% of the total annual rainfall. Total annual rainfall in the Jaisalmer area is around 160 millimeter per annum. Whereas at the margin of the desert in the near Jaipur region, the recharge was higher. 10 to 15% of the annual rainfall. That is, annual rainfall is there 600 millimeter per annum. So 10 to 15%. And also, the recharging capacity, it was found that, okay, with this information, particularly in the agriculture area, rain-fed agriculture area, 20% to 30% of the irrigation can be supported by minimum 300 millimeter per annum rainfall. So, and this type of irrigation is sustainable. So how we are using a lot of water, as I said, the 90% of the water, fresh water, being used for agriculture in India. So if you try to understand what the recharge capability and the domain, probably we can restrict the use. The technology is going to be the good answer. I tell you, I was talking to Dr. Prakashji that in some country, I am forgetting the name, they are using the remote sensing data to understand how much a particular crop needs the water, when it needs the water, and what quantity it needs the water. So they are regulating their irrigation system on the basis of the satellite data. So that can also happen in India, so that we can minimize the use of water here. Then the groundwater quality, I said the large number of pollutants are we're going to aquifer and how we can manage. I mean, of course, the vulnerability map and all that needed, and we are being done that, but that need to be intensified. We have such type of vulnerability map but in pockets and pieces, we need to have over a large area where I mean, lot of contamination and pollution taking place. We need to understand that the mobility. There should be also a strict regulatory measure to ban or impose fine on the polluting industries, and also the farmers should be, taught, or they should be trained, or should be tutored, mentored to use the organic fertilizer rather than the chemical fertilizer. So this way, probably we can minimize, And then the wastewater, we are generating a lot of wastewater. How we can use the wastewater? Of course, in Delhi and some part I have seen, and here also, the grey water is being used for the gardening purposes. And but still, in many places, we are using the water for our fresh water for the car washing, for the gardening and all that. Considering the severity of the water resources, we need to plan how we are going to use it. Wastewater could be a good pollutant, but also could be a good resource. This could be used as alternative source of water in many cases. But of course, you need to reclaim it. You have to, treat it, and of course, it is energy intensive, and there's some research may be done how to use it. Of course, for the many thing for the AC, we are starting using the solar energy. Why not we can use solar energy for treating the wastewater? So that become economically viable proposition. Then for the climate change, I said, well, climate change, either you mitigate the causes or adapt to the situation. Mitigation is not possible. So what we should do, we should have a technology to adapt to it. And there are 11 technology which have been identified for various purposes: diversion of water supply, groundwater recharge, then preparedness for emergency water events, then resilience to water quality degradation, then you have stormwater control and capture, and water charge. So these are the scenario for which we have the 11 technology which can be used singularly or togetherly as the need arises for adapting to the situation, to the consequences arising out of the impact of the climate change. This is how our groundwater and global water use is evolving. It gives a very sorry figure. You see, in the three sectors: agriculture, industry, industry and domestic. So how much? Yeah. This, you see, this much we are drafting, okay? We are abstracting. In fact, we are using this much. So this much is getting wasted. Okay. Yes. So this is how much, I mean, this is we are wasting. in agriculture sector, this much you are wasting in industrial sector, and this much you are wasting in domestic sector. So the lot of wastage is there, and this is here. The ethics is required. Well, you need water. If you need a half glass water, you half glass water. Why you put the full glass water and then you throw the half glass water? So that type of consideration, that type of ethics we need while using this resource if you want sustainability to be there. So what, I mean, for this all, we need a partnership approach where all should come together, work for the sustainability. Everybody, institution work in isolation. There should be, I mean, a integrated work culture so that something we can move ahead. I mean, mass awareness program should be, if we come together, we can have a mass program, awareness program. We can make people to understand that we need to value the water. Valuing the water means not the, I mean, it should have some economical value, but the value should come in your thought process. Whenever 5 people meet, they start talking about politics. So that situation should be like that. When the 5 people come together, they should start talking about the water. If that scenario is achieved, probably we will be much, I mean, we're doing a very good thing, a good work. Then we should make people understand there should be compliance of the regulation. It is not that there is no regulation to manage the water resources. They are very old regulations, but government make the regulation and then forget it. The government is not going to lose the vote. Government totally work for the vote, see, but the general people suffer. So there are regulations, good regulation to manage the water. Even the groundwater authority was created to manage the water. They declared many blocks as overexploited. They made the rule that nobody, such things will not be allowed. But okay, they made a rule, but who bothers? But it is a public, I mean, resource is a community affair. Resource must be managed by the community. Government is not going to come and tell you that, okay, do this or do that. It is the people perception. It is people initiative. It is people attitude. We should come together to work for the water. Then empowerment through training, research. There should be good, I mean, training for the different stakeholder, different people. I mean, even training for the people who are teaching the subject, who are working for the sub theme in the respective central and state government institutions. And so time to time, some training should be there, how things would advance in the right direction, and research are needed. And besides the ethical practices, it is very important. You have to bring in ethics in all your work related to the groundwater management. When you're doing research, when you are imparting training, when you are doing mass awareness, when you are looking for additional sources of water, whatever you are doing related to water, that should be, ethics should be there. That, okay, this is something which is needed for the survival and sustenance of this planet. And you are also a part of it. So that should, ethics, if you have that ethics and sense and responsibility in our mind, then only probably we can work efficiently. Of course, we need to have a population policy. I mean, an urban growth is less than the rural, we know, and we need to have because more, we have already crossed 8 billion in November. So water availability is directly linked with the number. It is number game. So if you don't control the population, then the water demand will go on and go on. And you cannot meet the water demand indefinitely. If this hall has a capacity to house 100 people, can you house, can you make it 200 people? You can't. So this planet has a carrying capacity. All the resources are finite. It is not that the water is infinite. The Dublin principle, the 4 principles, where the water resources have been made, considered that is a finite resources, not infinite. People perception is that ऊपर से गिरता है, ये तो बिल्कुल खूब आराम से मिलता है, everything is in abundant. No, there is no abundance. It is a finite resource. And with the finite resource, you cannot, manage the infinite population. So you should have a very good population. Conductive use of groundwater and surface water should be there. Because it is very easy to put a pump. Everybody having money and put a pump and get the water. You don't get the water, then the bank money goes. आप बैंक से लोन लेकर करते हो, नहीं मिलता बैंक को, कहते भैया नहीं मिला हम कहाँ से दें, बहुत ज़्यादा कुछ किया तो बहुत से farmers suicide भी कर लेते हैं. That is a different story. But yes, in case of Punjab, for example, Punjab, named after 5 rivers. और वहाँ पर आप देखिए तो irrigation जो है, that irrigation 26% of irrigation is only made by the surface water. Rest by the groundwater. Why? So, and many places. So we should have a conductive use of groundwater. Then we are exporting many commodities. We are doing here by using more and more water. We are developing commodities with high water footprint, and we are exporting it. Of course, for what we need, if you are growing fine, but for you should replace it. If you export it, but you export such a commodity which has a low water footprint. For example, beef, we are exporting too much, and it has very high water footprint. So such policy is required. Then siting of recharge surface, subsurface storage site need to be considered, properly sited, and construction of subsurface dam to stop the escape of the groundwater. Well, these are the areas to recognize because time is, I think, too much there. So these are area of research. So this is again, and if you see, the important thing here is how we manage our rainwater. This is again a stanza taken from the third Ved, that water which came down from heaven, that is rainwater, I should say, those spring up their own, the bright and pure water that finally reaches the sea, may this divine water may protect me. We are losing around 1200 cubic kilometer water to sea every year. Approximately 1200. So if we are able to adjust this water on the land, probably much of our problem will be solved. Then this is the last one. Let us join hands to put the water in mind of everybody. That is, so that everybody start thinking about the water. So thank you very much for your precious time.
Thank you so much, sir. It was an important and excellent talk. Like starting from with a very interesting quote from Atharvaveda and ending also from a quote from Rigveda, and regarding various goals to transform the today's world and characteristics of the groundwater, and finally the policies are to be set. And for sure, I think the talk had alerted us also to use the every drop of the water in a responsible manner. I think it needs one more round of applause to sir. And I now request our director to felicitate our guest today. It is a pleasure for us. Sir, with your permission, can we take few queries? If anybody wanted to. Acha, chat box. Okay.
Yeah. Hmm?
I think there are two. The question.
That's observation, I think.
It's like a observation. Is there any other? No? Acha. Thank you.
Monitoring is very important aspect, no doubt about it. We'll have to, because for that, I suggest the hydrocensus work should be taken all over India. That hydrocensus means the water level, aquifer level, and the water quality monitoring. These two things should go together all over. I mean, in the piezometer, of course, that need to be monitored. But if you develop a program and policy, effective policy of carrying out hydrocensus all throughout India, that will be useful. Depending upon, because we have, I think, 8 groundwater provinces with a different aquifer composition and character. So we can devise our strategy accordingly.
Thank you, sir. If anybody from the audience would like to, please.
Yeah, very good evening, sir. I have two questions. One is related to philosophy and one is science. So first, I would like to ask science-related question. That is, you mentioned about something about subsurface dams. Can you please elaborate that?
Subsurface?
Dams.
Yeah, it is. When you are able to understand the flow direction of the groundwater, and groundwater flow direction is follow the gradient, and it is said that it follow the topography. Okay, so then you can develop a trench, deeper trench. You can construct dam, depending upon what is the, and it should be across the aquifer. Okay, it should be across the aquifer. I mean, suppose you have a, for example, you have a multiple aquifer here. Okay, so I mean, and this aquifer, or say, for example, single aquifer you have, and you know the aquifer, and then you have a, non-aquifer material here, overlain, underlain. So you should vertically construct a dam which should cross this aquifer.
Okay, sir. Thank you. And
It's the same thing, sir, as subsurface dike. Is it the same?
It is a dike. It is subsurface dike, in fact.
yes, sir. Very much thank you, sir. And the
It
second.
is just like a check dam which you construct on the surface, depending upon again the surface flow. What is the thick? I mean, what is the depth of the flow? Accordingly, you develop a check dam. Accordingly, you have to go down the surface and develop it.
Yes, sir. Thank you, sir. And the second question, like you said, awareness among public, and the term one you mentioned, like enthusiasm should be there in the public towards the water, saving water, and means making amendments toward this artificial recharge and all. So can you tell me how this social media is means now frontline media is social media, I guess, in this current scenario. So how is going to play a role?
Well, that's a good question. That how many people are doing this thing on social media? That matters. One thing. Second thing, for example, as a president of INC-IH, this year what I have done, we have not many members. I wish all of you youngsters should become members. What I have done, the members are from the different part of the country. Okay, not only the social media work. Social media is okay, but if one-to-one contact, that matters. I mean, I have requested many of the members to act as the envoy of the INC-IH in the respective area, in the respective institution, and to deliver time to time lectures to the student, to the farmer community, student community, okay? And they will be definitely benefited if you go and meet them personally and tell them, understand their problem, interact with them. So this work I had done, I mean, I had a small project and I used to go with my, laptop and also my projector to respective school in Jaipur and you to deliver a lecture of 10 and 12 because I understand the student of 10 and 12 class are in a very formative stage. They can understand because they are going to higher education. So I used to deliver them and I used to tell them what are you are, I mean, so many things, but one point which I very well remember that whatever water you are getting through the pipeline, it is not a free water. This water has been taken out, then processed. It's not that you are getting simply, from the well. This well, I mean, the water is being taken to the processing site, it's being processed, and then you are being given. It has some value. So it is not a free. Similarly, and you use this free water for your bike washing, car washing, this and that. So you will be wasting. So you have to plan accordingly. And there's so many things. I mean, you have to convince them that water need to be used very reasonably and effectively. Because I have heard that many people taking the shower in a plastic, I mean, they're way, plastic tank. They stand in a plastic tank, they take the shower, collect the water, and then this water they put in there in a flower pots. This is some example and small things need to be practiced. And then it become a culture, if you people start practicing, then the more people will join you, it become a culture. So we should have a water conservation culture in the country. And this only the social media cannot help. Because everything, this many people don't, see the WhatsApp messages these days also. Because they're too much, too many, so many groups, everybody, one group is being made every day. So, and the important thing, I say that there are many important things also getting lost in such vagaries, you see. So, still I believe that contacting, I mean, personally, that is more important in conveying and convincing your point of view.
Yes, sir. Very thank you, sir, for your suggestions. Like you said, one innovative idea, like bathing in tub and saving that water. But I will just take few more minutes of yours.
Yeah. Can we have a discussion little later? We have one more question from the online. Actually, Rajesh ji thanked you for answering his observation and question. And one more question from Dinesh ji. He wanted to an elaboration on government policies and ground subsidence and groundwater pumping regulation. He wanted to have an idea about the government policies. You can just government policies on ground subsidence and groundwater pumping regulation.
Yeah, there is a regulation. I mean, I just mentioned that the groundwater authority was constituted by the ministry only to regulate the use of groundwater in the India. And the groundwater, I mean, this authority have, I don't exactly remember, declared many zones as a dark zone, overexploited zone. And there the pumping are not allowed, okay, prohibited. But, I mean, how far this regulation is being complied with, which is a matter of matter of subjectivity. Okay.
Correct. Thank you so much, sir.
Yeah. Yeah. Please.
Please.
Yeah.
Because
Sir.
you are a practitioner. I also a scientist.
Yeah, as far as groundwater regulation is concerned in India, actually Central Groundwater Authority has been formed, and there are different state agents, regulatory agencies also, which are managing the resources. As you have said, sir, they have now extraction charges also they have been implemented. It means if you want to extract some water for industrial use, more particularly the industrial use, so whatever the amount you wanted to, that amount of quantity of water you wanted to use,
That
so
is defined.
based upon that they are charging, and the state also such regulations are there, but charging we are not doing. The Telangana we are not charging anything right now, but we are controlling.
Remember, yes, you are very correct. That, for example, in Jaipur, near Jaipur, there was Coca-Cola has established a factory. They were not getting, because for there you have to get environmental clearance for all your activities. Okay, and it is part of the environmental impact assessment. So they were asked, okay, we will allow you to abstract a particular volume of water, but you have to recharge, you to develop recharge structure, of 1.6 times of the required quantum. Suppose if you need 100 liter, then you need develop a structure where you can recharge 160 liters. So this was this is a part of the regulation. Very correct.
Thank you for the elaboration and knowing us the policies. I think if Dr. Devishish, no? Okay. So if Dr. Mahek, please.
Yeah, thank you, sir, for very thought-provoking talk. With the reference to the recharge from flood water and rainwater, if I remember well, in 2002, Supreme Court have asked by then government to form a committee on interlinking the rivers. Yeah, and it was also project much out by then Prime Minister Atalji. But 2 decades have passed and nothing seems coming out. So it seems it is, I mean, feasible first of all because of topography and all these things. And will it solve the problem?
Yeah, it was earlier conceived as a Garland project, and then it came as a river linking project, and it was more than 4,000 crore project. So this was not found economically viable. But yes, local level, it was carried out. I think in Madhya Pradesh, it was carried out in Rajasthan also. The local channels were connected. With the ephemeral river system were connected with the perennial one to bring the water. I exactly don't remember, but on a national scale, it was not done. And it probably, this idea have been saved, because of the economic consideration. And it was thought that it is not possible to transfer Himalayan river water to southern river water. It is not possible directly. Yes, in the local linkages can be developed, and that has been developed in the country in some part.
Thank you. One more is there, but I think this is already answered. That is, can you please elaborate on water security in our country? This is by Asima Mishra ji. I think it is.
Water security means, your water needs to be made. I gave you one example, which was a project which we carried out in Rajasthan, in 100 villages, and it was pertaining to water security. So, everybody needs some water for drinking purposes, for other purposes. So per capita requirement of water is there for the person. For example, if one person need 100 liter per day, then a family of 5 person need 500 liter. Okay. Similarly, the animals, they also need water. So that also need to be taken into consideration. Okay. Then the plants, also needs water. So that calculation has to be, if you go on that level, then all the calculation you do, and suppose per family, you need, 1,000 liters of water per day, and you are getting it, this means you are water secured. If you are not getting, this means you are not water secured. This is what a basic proposition is like this.
Thank you, sir. I mean, by seeing the queries, we can think of the importance of the water in our daily life as well. So thank you very much, one and all. And now I would request Dr. Subhashis to propose vote of thanks. Subhash.
Good evening. Professor A.K. Sinha, Vice Chancellor, Chhatrapati Shivaji Maharaj University, Maharashtra, Director NJRI, Director AP Telangana Groundwater Department, Professor Venkatesh sir, and Dr. Arel sir, Verma sir, Thangarajan sahab, and my dear colleague. You have seen a very holistic talk on World Water Day, covering the entire aspect and stressing upon the accelerating effort to make the sustainable groundwater resources for our better future tomorrow. The Sustainable Development Goal, which was set in the year 2015 to have a clean water and sanitation for all by 2030. Recently, the UN Secretary General, Mr. Antonio Guterres, has expressed his concern that the world is dangerously and dramatically off the track to achieve the above goal. And the water problem is worse in India, sir. You have mentioned that base flow, which is reducing day by day. Even we got one request on the Sahi River, which is a subtributary to the Ganga River, covering, passing through parts of Gorakhpur, those regions. And the State Department started digging deepening the bottom of the river, thinking that the water will come. Certainly that is not a solution. And I'm happy to inform you, sir, that NJRI with this basic knowledge of, advanced knowledge of geophysics, started aquifer mapping first time perhaps in the world, because that time, even while debating the aquifer mapping was, how can you do it? But then we started under the umbrella of then Ministry of Water Resources with the Central Groundwater Board, covered the 6 typological area representing almost entire geological terrain of the country as well as the world. And we have come up with the knowledge of even the fracture system. Even after establishing, we are now, like you have mentioned, the pace of the mapping and management through the knowledge base. So last year we have covered 1 lakh square kilometer area in 1 year with the 40,000 line kilometer of data added with the ground geophysics and hydrological data. That was one landmark achievement. And idea is to cover the entire 4 lakhs square kilometers starting from Himalayan foothill, that is parts of Himachal Pradesh, to full of Punjab, full of Haryana, to the half of Rajasthan towards west of the Aravalli, and up to the sea coast, Saurashtra and Rann of Kutch. So having a comprehensive understanding of aquifer system starting from soil to the top 500 meter deep, and the main stress is to rejuvenate and enhance the recharge to achieve the sustainability. And our idea was actually to and in fact, one of the major findings is that we have discovered a paleo river, which is 160 kilometer under 50 meter of alluvial cover. So, and of course, the aquifer mapping, all those things are there, but these are something which we are going to continue. So we are on the same track, and The World Water Day also reminds us that it is not only institutional responsibility, but rather it is individual as well as collective responsibility to achieve this goal of sustainability, to have a better future tomorrow. So with this, I thank you very much for covering the entire aspect. And I must thank to Director Injari for taking a special interest to arrange this talk and making all necessary guidance and to organize this talk, and even calling all the senior scientists. Actually, he has taken a special interest. I can feel it. Thanks to our, Director Telangana and Professor Venkateswar Rao Garu for coming all the way for such a long distance to come and attend this talk. Dhar sir, and all my dear colleague and organizing committee for arranging this talk, and all the support staff. So thank you very much, one and all.
I once again heartily thank Dr. Prakash Kumarji for giving me this opportunity to be here amongst the very learned community of the scientific community of NGRI. It is a very internationally, nationally very reputed organization. And I've been coming here for quite some time. Of course, in the recent past, I couldn't come, but I was so happy after having a talk with Dr. Mandal, Dr. Subhash Sanjay, the type of work being carried out by NGRI. And also it gets reflected in the, the publication which is coming out. It is number one, institution. In the publication wise, it is a number one institution in the country. So I'm really enlightened to be here, and I'm really grateful to you. Thank you very much.
Thank you. Thank you for your kind words. And I would request all of you to raise for the national anthem. And I sincerely request Dr. Dhar sir and Dr. Devendra to sing the national anthem, if it's a sincere request.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल जमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Small announcement. Please join all of you to a high tea near the car parking main building.